Bismillahirrahmanirrahim. In today's lecture, we are solving problem 1-67 from the book Thermodynamics and Engineering Approach by CENGEL 7th edition. So, the problem statement is a gas is contained in a vertical frictionless piston cylinder device. The piston has a mass of 3.2 kg and a cross sectional area of 35 square centimeter. A compressed spring above the piston exerts a force of 150 Newton on the piston. If the atmospheric pressure is 95 kilopascal, determine the pressure inside the cylinder. Inside the cylinder as gas, it means that find the pressure of gas. So first I write given data. So in given data, the mass of the piston, mass of the piston MP is equal to 3.2 kilogram, and a cross sectional area of piston is equal to 35 square centimeter, and convert this to square meter. So divide by 10 power 4, 10,000, because when I convert centimeter into meter, then I divide it by 100. So square centimeter, and in case of square centimeter I will divide this by 100 square, and 100 square is equal to 10,000 meter square meter, which is equal to 0.0035 square meter. So a compressed spring above the piston exerts a force of 150 Newton on the piston. So force of the spring which is downward. Spring exert force on the piston. It means that it exerts force on the piston in downward direction. So force of spring, and this is downward force. Which is equal to 150 Newton. If the atmospheric pressure is 95 kilopascal, PATM is equal to 95 kilopascal. Determine the pressure inside the cylinder as gas. It means that find the pressure of gas. Solution: according to equilibrium condition, conditions, downward forces will be equal to upward force. Downward forces will be equal to upward forces, or upward forces will be equal to downward forces. So there is one upward force, force of the gas working fluid inside the cylinder on the piston, and all other atmospheric force is in the downward direction. Similarly, force of the spring is in the downward direction, and similarly weight of piston is also in down. This is three forces are in downward direction and one force is in upward direction. Force of spring is in downward direction. Similarly, weight of piston in the downward direction, and similarly atmospheric force is also in downward direction, and the force of gas or working fluid is in upward direction. Three forces are in upward direction, downward direction, and one force is in downward. And this one force will be balance the three downward forces. So the system will be in equilibrium. So upward forces will be equal to and downward force. So upward force is force of gas. Force of gas is equal to weight of piston plus spring force plus atmospheric force. So force of gas or working fluid we can write as we need it, P is equal to F by A. So F is equal to PA. So F of gas mean I can write this as pressure of gas multiplied by area of piston, because the pressure of this is on the piston, this force is on the piston, pressure of gas is on the piston. So I can write this F of gas as P of gas into AP. Similarly, W of T is equal to mass mg, mass of piston multiplied by acceleration due to gravity. If is force of spring is given to us, and force of atmospheric force is equal to P multiplied by A, atmospheric pressure multiplied by area of piston, cross-sectional area of the piston, because atmospheric force is on the area of the piston. So now putting wheels and find P gas. So P of gas, both sides divided by area. So MP multiplied by G plus Fs plus PATM multiplied by cross sectional area of piston divided by area cross sectional area of piston. So pressure of gas is equal to mass of piston is given to us is 3.2 kilogram. Acceleration due to gravity is 9.81 meter per square second, plus force of spring is equal to 150 Newton, plus atmospheric pressure is equal to, atmospheric pressure is given to us is 95 kilopascal, and 95 kilopascal is equal to 95,000 pascal, and pascal is equal to Newton per square meter. So this is equal to PATM is equal to 95,000 Newton per square meter, and area of piston is 0.0035 square meter, and hole divided by area of piston, which is equal to 0.0035 Newton per square meter. So pressure of gas which is required is 3.2 multiplied by 9.81 is equal to 31.392 kilogram meter per square second is equal to Newton, plus 150 Newton. This is area, this is just equal to square meter, not Newton per square. This is area, plus 95,000 multiplied by 0.0035 is equal to 332.5 meter square will be cancelled with meter square, and this will be equal to Newton divided by 0.0035 square meter. Now we further simplify this. So if I add these above three videos, so pressure of gas is equal to 31.392 plus 150 plus 332.5 is equal to 513.892 Newton divided by 0.0035 square meter. So pressure of gas is equal to 513.892 divided by 0.0035 is equal to 146,826 pascal. 826 pascal. Newton per square meter is equal to pascal. Now we want to convert this into kilopascal, so divide by 1000. 1 kilo 146,826 kilopascal divided by 1000. Kilo is equal to 1000, so multiply and divide by 1000. So pressure of gas is equal to 146,826 divided by 1000 is equal to 146.826 kilopascal. And if I round it, so this will be equal to 147 kilopascal. And this is the final answer. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.